Hi, I'm Nikita, a software product marketing engineer at Intel. Today I will shed some light on the Intel oneAPI threading building blocks or oneTBB library that provides you with functions, interfaces, and classes to add parallelism to core C++ applications without being a threading expert. It lets you specify logical tasks instead of threads with emphasis on data as well as task parallelism. oneTBB is ideal for a wide range of compute-intense domains such as numeric weather prediction, oceanography, astrophysics, genetic engineering, seismic exploration, AI and automation, energy resource exploration, and socioeconomics. In this video, I will talk about the latest features brought to you by oneTBB version 2021.11 for efficient CPU utilization. I will also discuss some of the major functionalities that the library offers, namely concurrent containers, dynamic memory allocation, and task scheduling. Simply using the library's templates, you can leverage multi-core hardware capabilities by making your program portable, scalable, and composable, giving you maximum parallel execution flow design flexibility. Version 2021.11 of the library provides early access to the oneTBB Composability Manager feature, through which oneTBB can coordinate with Intel OpenMP runtime on CPU usage when both the runtimes are used within a process. Set the TCM enable environmental variable to 1 for enabling this feature. At any given point of time, each runtime uses only a portion of CPU that was negotiated with the other runtime. This prevents overutilization of the limited number of available CPU resources. A container in C++ is a purpose-specific data structure that stores objects and controls their allocation and deallocation. Unlike the sequential containers of the C++ Standard Template Library or STL, oneTBB provides you with concurrent containers, enabling multiple threads to concurrently access and update items in the container. The more traditional approach of wrapping an STL container in a mutex would also mitigate access conflicts by allowing only one thread to be operated on the container at a time. That approach, however, restricts concurrency. Concurrent containers provide an elegant alternative. Note that operations on highly concurrent containers take longer than on STL containers, so such containers should be used only when their additional concurrency outweighs their slower sequential performance. oneTBB provides several memory allocator templates that can handle challenging tasks in parallel applications, such as moderate memory consumption, quick memory allocation and deallocation among threads, avoiding reaching of cache associative limits, and keeping allocated memory hot in the cache. Also, there are templates that allow you to efficiently mitigate and allocate resources to avoid two critical issues in parallel programming. First is scalability issue, where memory allocators designed for serial programs are used on threads competing for a shared resource, such that only one thread is allocated at a time. And second is false sharing problem, where a process modifies a cache line and another process reads the same cache line even before words on the cache line get updated. For a common task to be performed on large-sized inputs, data parallelism helps distribute the same task among multiple computing resources, while for operations involving multiple tasks, task parallelism lets different computing resources handle different tasks. oneTBB allows you to benefit from both data parallelism and task parallelism. For efficient thread-based programming, you should have one logical thread of the program mapped onto one physical thread of the hardware to avoid undersubscription or oversubscription. Instead of threads, oneTBB formulates your program in terms of lower overhead logical tasks. You only need to concentrate on the logical dependencies between tasks. The library's task scheduler takes care of their efficient scheduling. It does load balancing, that is, efficiently assigns tasks across threads and cores. It manages sizing and timing of parallel workload tasks such that they scale well without causing locks and waits. It also helps with faster initiation and termination of tasks, along with deciding on their efficient evaluation sequence. In this video, I discussed about the new feature of oneTBB and some of the crucial tasks that the library handles, namely data parallelism through concurrent containers, dynamic memory allocation, and task scheduling. I encourage you to get started with scalable parallel programming using oneTBB. Detailed resources to know more about it are available in the video description. Experiment with the oneTBB code samples available on GitHub and try your hands on the library on Intel Developer Cloud Platform. Thank you for watching.